Let's talk complexity and chaos. These are two words associated with trouble in our lives. The word trouble is used because when adversity strikes, we instinctively attribute it to the influence of complexity and chaos. Of course, at this point in time, we are just referring to these two words in a generic sense. However, later, chaos and complexity will be explained in more detail. They will take on a much more defined meaning in your life. It's natural to assume that when actions occur in our lives that we deem detrimental to our safe existence, the human brain always defaults to the idea that things must have gotten too complex or chaotic. Otherwise, the detrimental actions would never have happened. However, when events take place in our lives that represent the pleasant side of life, such as welcoming the birth of a healthy baby, achieving a college graduation, savoring a memorable vacation, or randomly choosing the correct numbers to the next Powerball lottery, we don't give credit to chaos or complexity for the positive outcomes, even though these very factors play the entire role in shaping these fortunate events as well. Now that we know that we depend on chaos and complexity to deliver both good and bad events in our lives, we also need these two interconnected drivers to deliver indifferent things in our lives as well. An example of indifferent would be making a pot of soup for lunch. You wouldn't place this event in the category of bad, nor would you place it in the category of good. The taste of the soup might be a positive addition to your nutrition and pleasing to the palate, but the preparation time and cleanup time involved are squarely placed on the negative side of the equation. Actions and events that are indifferent kind of hide themselves in the middle of having both small positive effects and small negative effects in our lives. We as human brains really don't take notice of them, as they are just tiny, fleeting moments in our always present time. We often overlook these fleeting moments amid the constant flow of our eternal seconds, reserving our attention for the major catastrophes and triumphs that stand out in the pages of our experience. You are about to get a crash course in chaos, complexity, and systems theory. Don't worry, it will be simple, visual, and easy to follow. Right now, we are just laying the groundwork and introducing concepts that will come together as we move forward. As humans, we are inseparable from the world around us. And as such, we are not only susceptible to the influence of chaos and complexity, but also capable of orchestrating them as well. Consider those who decide to drink and drive, leading to the tragic death of an innocent person. In this scenario, the inebriated driver becomes both the creator and distributor of chaos, not only affecting the life of the victim, but also sending ripples through the lives of the victim's family members, friends, law enforcement, and the extended participants of a vast criminal justice system. The adverse effects of such decisions endlessly trigger catastrophic events forward in time, demonstrating the boundless reach of cause and effect. The discipline that deals with nonlinear, chaotic, and complex systems is called systems theory. The type of systems we will be concerned with are called nonlinear dynamical systems. Don't worry, we'll define and make clear these terms. This is where chaos and complexity show themselves in a different light than in the generic way we discussed earlier. Remember, we are discussing systems so intimate to our lives that we cannot ever separate ourselves from them. These systems come with two personalities that make life on Earth, for every human brain, an enjoyable stroll in the park or a frightening ride on a runaway freight train. But before we get into explaining nonlinear dynamical systems, let's discuss what a system is for anyone not familiar with the subject. The word system is another generic type of word that we use daily without ever thinking about the exact definition. Throughout this video series, you will hear the word system many times, so let's define it here. In scientific terms, a system can be defined as a collection of interacting and interrelated components or elements that form a complex whole. To study a system requires knowing the relationships and interactions among these components to understand their collective behavior. Most of us know that an automobile engine or a machine that manufactures parts would be considered a system. each of them having multiple components working together to form a complex whole to achieve a specific operation or multiple specific operations. But systems also come in more abstract forms as well. Consider the stock market as a tangible illustration of a real-world system. It represents a dynamic assembly of interconnected constituents that collectively shape the complex, intricate entity we recognize as the stock market. Within this system, you encounter a diverse array of components, such as traders, brokerage firms, market makers, analysts, liquidity providers, and computers. When these elements synergize, they coalesce into the cohesive and multifaceted entity that we label the stock market. A parallel example in our human experience is the medical system. This system is made up of an amalgamation of health professionals, hospitals, pharmaceutical companies, research labs, insurance companies, and the spectrum of diseases that impact human health. Each of these elements plays a role in constituting the intricate whole that defines our medical system. While we could list thousands of systems and their respective components, the core concepts remain clear. It's crucial to recognize that these systems often intersect and overlap, making for an intrinsically messy world where boundaries of systems bleed over each other. A prime illustration of this intersection unfolds when a pharmaceutical company unveils a groundbreaking drug, leading to heightened stock activity on the New York Stock Exchange. This success not only influences the pharmaceutical company's stock price, but also holds profound and enduring implications for patients benefiting from the newly approved medicine. The repercussions extend across both financial and medical domains, showcasing the interconnected nature of these systems. Systems exist in chemistry, physics, economics, sociology, business, biology, and many other disciplines. Generally, they fall into three categories: simple linear systems, complicated linear systems, and nonlinear dynamical systems. These latter type systems are shaped by the interaction of many components and influenced by chaos and complexity. As you move through Right Side Blind, try to shift your perspective beyond the familiar. Imagine gathering every system on Earth, including those you've never considered or even known to exist. Now let's merge them into one vast, all-encompassing entity we'll call the majestic nonlinear. Think of it as the system of all systems. It includes everything and everyone across all places and times. From this point forward, whenever we refer to the majestic nonlinear, we mean the vast interconnected system in its entirety. To visualize this, think of the entire Earth, not just its surface, but everything within it, on it, and arising from it. This is the nonlinear world that humankind must navigate and compete against every second of existence. You and every other human on the planet are not distinct entities separate from the majestic nonlinear. Nothing and no one is separate. We and everything that exists are of the system, in the same way atoms and molecules are of or constitute the makeup of a thing. Unlike being in something, we humans are of the majestic nonlinear, not merely contained within it. This concept is paramount for the viewer to grasp and acknowledge that every human brain cannot disentangle itself from the majestic nonlinear system. The system cannot be defined without defining us as human beings, nor can human beings be defined without defining the system. Consider a fish in water, capable of being lifted out onto land. This signals it wasn't inherently of the water. In contrast, an underwater current is of the water. We could not extract it and place it on land, nor can we scoop an ocean wave into a bucket and take it home for the family to view it as a wave. Similarly, we, as fellow human beings, are intrinsically intertwined with the majestic nonlinear. We are defined by it, possess agency within it, and are subject to the diverse degrees of freedom and constraints that are inherent in the example of the underwater current in the aquatic environment. This, in essence, encapsulates our existence. From here on in, when you are presented with the majestic nonlinear, think of the entirety of the environment every human plays, works, eats, sleeps, and experiences life within. It's now time to immerse ourselves in the heart of what this whole thing is all about. Systems theory, system dynamics, nonlinearity, chaos, and complexity are all easy to understand as subjects. What makes it difficult is the way they're taught by academia. Right Side Blind will fix that problem by teaching this subject in a slightly different way. For instance, if you were told that chaotic systems are highly sensitive because of initial conditions, and that complex systems give rise to emergent phenomena through the interactions of many components, this might sound purely academic. At first glance, it would seem to have no relevance to your life. However, understanding these principles is essential to your survival as a human being. You constantly navigate a world shaped by both chaos and complexity, where small actions can lead to unpredictable consequences, and systems evolve in ways no single individual can fully control. Right Side Blind is here to help you see and visualize this nonlinear reality, making it not just an abstract concept, but a tangible force in your daily experience. As a human being with a human brain, your ability to survive and achieve happiness does not depend on obtaining a PhD in nonlinear dynamical systems or systems theory. Understanding a few basic principles that govern our world is sufficient for attaining safety, security, and happiness. As children, we were all taught countless hours about how to love, have gratitude and empathy for others, which are all virtues we should pursue in our lives. But we were never taught survival skills that were vital to understanding our place in this world. Perhaps this comes from the idea that our existence here on Earth cannot be defined independently without also defining the entirety of the system itself. Alan Watts, a 20th century philosopher of Buddhism, Hinduism, and Taoist ideas, once wrote, "We do not come into this world, we come out of it, as leaves from a tree, as the ocean, waves, the universe, peoples. Every individual is an expression of the whole realm of nature, a unique action of the total universe." So, where did this nonlinear dynamical system idea come from? A nonlinear dynamical system is a system in which the relationships between things are not proportional. This means that a change in one thing does not result in a consistent or predictable change in another. This lack of proportionality leads to behaviors such as feedback loops, emergent patterns, and sensitivity to initial conditions, which can result in complexity, unpredictability, and even chaos. Unlike linear systems, which can often be solved with straightforward equations, nonlinear systems require a deeper understanding of dynamic interactions and evolving states. Early scientists, especially during Newton's time, saw the universe as one big machine. Everything seemed to follow clear rules. People thought that if we could figure out those rules, we would be able to predict the future. That was the goal. If you knew how things started and what laws were in play, you could supposedly know what would happen next. This led to the idea of a clockwork universe. A French scientist named Pierre-Simon Laplace came up with a thought experiment. He imagined a super-intelligent being that knew where every particle in the universe was and how it was moving. If that were true, he believed, this being could figure out everything that would ever happen. For centuries, this was the scientific thought of the day. If we didn't know something about a system, we were simply ignorant of the underlying rules for that system. Over time, humanity had confidence that it would have Newtonian-like equations for everything in existence. That was until the early 1960s. Chaos theory was pioneered by mathematician and meteorologist Edward Lorenz. He revealed that even in simple, deterministic systems, unpredictability and chaotic behavior ruled the day. The famous example of the butterfly effect highlighted the idea of sensitivity to initial conditions. This is when a butterfly flapping its wings in Brazil could set off a cause-and-effect chain of events leading to a tornado in Texas. This sensitivity to initial conditions shattered the illusion of predictability in certain dynamic systems. But what does this and this and this have to do with right side blind and the human struggle for survival? Well, let's show you a visual example of the butterfly effect in a person's life. Remember, this applies to you and every human on Earth. As a matter of fact, it applies to zebras, cats, dogs, wild horses on the plains in Montana, and every other carbon-based entity searching for survival. This is Mark and Larry. They have been friends for some time now. They are standing in front of Larry's house talking to each other. Mark is in the red and Larry is in green. Let's get closer to see exactly what's going on. There, we are now looking down at Mark and Larry. This will be our starting point in following the progression of the butterfly effect in Mark's life. Mark doesn't know it yet, but soon he will be making a life-changing decision. Mark's mother calls him home to eat dinner. Mark has a choice to turn to his left or to his right to head on home. It seems like an inconsequential choice to make, but Mark has a date with destiny. From here on in, we will follow both Marks as one turned to the right to go home and the other turned to the left to go home. They don't seem that far apart and the differences seem minor, but keep in mind that both paths can never converge again. Every atom, every molecule and quantum state in Mark's bodies must realign perfectly for them to get back to the one timeline. That would be beyond an astronomical possibility. At this point in time, though, it doesn't seem that Mark's choice has much of an effect on his life. By the time both Marks get to the steps of their house, one of the Marks starts to take off his backpack early, while the other decides to take it off inside. The Mark that took his backpack off outside dropped his cell phone at the foot of the steps. The other Mark went straight inside. You can see divergence growing already. It is now dinner time. One Mark sits at the dinner table, enjoying a good meal with his family. The other Mark dropped his cell phone outside, causing the phone to break. He excuses himself from dinner and retires to his bedroom to take a closer look at the damage to his phone. The next day, at school, it would seem an opportune time to get these two Marks back on track into one timeline again. We would assume that both Marks must occupy the same desk and chair in first period math class. This should force both of them together at the same time and place. However, even occupying the same chair and desk, they are still on separate timelines. This shows that close convergence can take place without disrupting the divergence of both Marks. Keep in mind that throughout the lives of both Marks, they will separate far apart at times and converge closely many times. Let's jump to both Marks going off to college. Both Marks are planning to major in chemistry, and they both anticipate going for their PhDs in the subject. One Mark chooses Duke University because in December of his senior year in high school, he happened to be at a friend's house and was talking to his friend's older brother who attended Duke University. This Mark liked what he heard about the university, so he applied and was accepted into the Bachelor of Science program in chemistry. The other Mark, who never went to his friend's house that day, attended a college fair sponsored by his high school. At the fair, he happened to see a girl he really liked. He spent about 5 minutes talking to her near a table sponsored by Northwestern University. The man behind the desk got involved in their conversation and ended up introducing the university to Mark. There was an application sent to this Mark, and he was accepted into the Bachelor of Science program in chemistry. Throughout college, the two Marks continued diverging and converging over the years. Their schools are about 800 miles apart by automobile, but they share the same home between semesters. They each have new friends and new experiences and will spend spring break vacations in different destinations. Both Marks are now about a year away from completing their postgraduate work in chemistry. Both are working on their dissertations and preparing to defend them when ready. The Northwestern University Mark has forged a good friendship with his graduate advisor. The Duke University Mark has forged a good friendship with a local Army recruiter near the university campus. They met at a frat party 2 years before. The Duke University Mark has been fascinated by the recruiter's stories about his days in the infantry. And because of this, Duke University Mark decides to pause his education for the time being and enlist in the Army infantry. He scores high on his ASVAB test and is off to boot camp 30 days later. It is now late February 1991. Northwestern University, Mark has successfully completed his dissertation defense and will be awarded his PhD in chemistry. The Duke University Mark is on patrol in Kuwait, completing a special platoon-sized mission with the 1st Infantry Division. His job is to infiltrate a village and search for possible weapons, ammunition, and explosives left behind by Saddam's Republican Guard units. It is February 25, 1991, and both Marks are being tested. One is wagering his career and reputation among his peers. The other is wagering his life. At exactly 8:17 in the morning, the Mark at Northwestern University begins his dissertation lecture. As Kuwait is 9 hours ahead, the other Mark is in the middle of his mission at 5:17 in the evening. This is when chaos hits its tipping point in the Kuwaiti village. Mark's battalion comes under fire from Saddam's Republican Guard fighters. This was a trap. Confusion and panic hit the American troops as they search for cover, fire back, and radio in for aerial support. So how did we get from the picture on the left to the picture on the right, when both Marks started at the same place, in the same body? Remember when we introduced this man by the name of Edward Lorenz and his work in chaos in meteorology? Well, it was his work that can explain the stories of our two Marks. Even though his main work was in weather systems, he discovered a particular characteristic in chaotic systems. He found that tiny deviations or differences at the beginning of a system timeline can have extreme differences in the way the timeline ends up. This is what we call the butterfly effect, or sensitive dependence on initial conditions. You might be wondering what Ed Lorenz's work on weather systems and Mark's two lives have in common. This graph will explain it all. This is what Ed Lorenz might have seen when comparing two identical weather systems that start out together. The only difference is that one system turned left and the other system turned right, just like Mark did when being called home for dinner. This is where our weather system began at second number 1. We can now imagine it going to the left and also going right. At first, they are indistinguishable from each other. They only differ slightly, but they are different nonetheless. At the highlighted center of our graph, take notice at how the systems start to do more divergence away from each other. However, they still have a tendency to cross paths through this period. By the final days of the forecast, the two weather systems have diverged beyond any practical resemblance. Although they began from nearly identical initial conditions, countless interactions within the atmosphere have gradually amplified their tiny differences into entirely different outcomes. At this point, each forecast has effectively become its own weather system, following its own unique path through an ever-changing environment. The connection between them has not been broken by a single dramatic event, but by the continuous accumulation of countless small interactions over time. This is the butterfly effect in action. Small differences do not remain small. Given enough time within a nonlinear system, they grow into fundamentally different futures. This is the final ending to our butterfly effect within our weather system. Notice the difference in results over time. Let's now take a look at the graph representing Mark's life over the years. Does it look familiar? It looks just like our weather system that was affected by the butterfly effect. You might be asking what weather and Mark have in common. You will learn more about this later, but for now, Mark and the weather are both nonlinear dynamical systems that are driven by chaos and complexity. Take notice of the diverging lives of Mark in the end, when both timelines take on a life of their own. One timeline gets Mark his PhD at Northwestern University. The other timeline has Mark serving his country, under fire, in a land far from home. Before we finish this chapter, we must qualify the butterfly effect for what it is not. Just because we start Mark's journey through life at the intersection of turning left or right, that does not mean that the left or right turn decision is the sole variable in determining the end result. It is simply the first cause in a long line of cause and effect. This then leads to further actions of cause and effect down the road. You might be wondering what all this has to do with right side blind. Well, if you remember in the introduction video, you were told that the human brain needs to understand its environment. The butterfly effect is part of your environment. Just like Mark in the weather system, you can't be separated from it. It is always on you and of you. The human brain needs to learn that. Because of the butterfly effect, it is, for the most part, just along for the ride. The brain is told from birth that it has free will and control over its destiny. The brain holds tight to this concept, which causes it to blame itself when life does not go the way it was planned. The butterfly effect is our first introduction to an environment that holds more control over us than we do ourselves. So let us continue to the next video in our search for chaos and complexity.